just read the problem. Okay. It says I'm doing problem A on the latent heat practice questions. All right, let's write down some of the facts in the problem, okay? It says a pan containing water boiling at 100 degrees Celsius, okay? So the boiling temperature is 100 degrees Celsius, all right? Is standing on an electrically heated hot plate. In 20 minutes time, right away you're going to think that that's going to probably be with power. So let's convert that right away to seconds. So how many seconds are there in 20 minutes?
1,060.
What is it?
1,200.
What, 1,400?
200.
What did you say?
1,200.
1,200, very good. Or 1,200 seconds. Okay, good. And then it says the mass is 0.075 kilograms. And the latent heat of vaporization is going to be 2.25 times 10 to the 6 joules per kilogram. So the latent heat. But I don't like the way they do that. I say that, I think it's a little clear, heat of vaporization. And that's going to be 2.25 times 10 to the 6th joules per kilogram. All right. It says, calculate the energy used to convert 0.075 kilograms of boiling water to steam. Now, the first thing you want to do is you want to check to make sure that everything is SI. All right. So temperature is Celsius. That's good. Your seconds, minutes were changed to seconds. Yeah, that's good. And then you have kilograms, which is correct. Yes. And then you have joules in kilograms, which is correct. All right, now you want to calculate the energy. What's the equation for calculating energy for water going from liquid to steam? What's the equation? All right, so I'm going to film this. That means you don't have to do anything, or no, you have to do something. You have to talk to me. If I ask you a question, you have to answer me, right? They're stunned. They don't know how to behave. I'm filming. They're stunned. What's the equation? No? No idea? Right? Mass times the latent heat of vaporization. In this case, 2.25 times 10 to the 6 joules per kilogram, correct?
Yes.
Yes? So it's going to be, the energy is going to be equal to 0.075. You can leave off the unit labels now because why? Everything is in SI units, everything will cancel. We did the dimensional analysis, so you're good. That's why you do dimensional analysis, so that you can simplify your calculations. Yes? All right? And then you're going to multiply it by 2.25 times 10 to the 6 joules. We can leave that off. All right? So what's that answer? Give me a calculator. Help me out, please. Can't do everything. So energy is what? The energy equals what?
168,750.
All right, give me just a few significant figures. Give me two significant figures. We only have two there. 170,000. Is that right? Like that? Joules? Yes? All right, good. So now let me erase some things. It says how much energy is, that's all they're asking? That's it? That's the entire problem? Somehow I think that that is not going to be the entire problem. But, all right, fair enough. That's the entire problem? Really? Okay. So that's A. I suppose there is more of a problem there. They just took that one out, so we're done. That's A. All right, let's do B. All right, it says B, how much energy is needed to melt 100 grams of ice? 100 grams of ice. How much energy is needed to melt 100 grams of ice? So what's the equation? Same equation? Yeah, same equation. Let me do it the way I do it. It's going to be MHF. Because L could be fusion or vaporization, right? All right. So, what is HF? The heat of fusion is going to be 330,000 joules per kilogram, right? Okay. And then the mass, that's going to be HF. And then the mass is going to be what? 0.075? No. 100 grams. So what do I have to do right away? Convert it to what? 0.1 kilograms. Correct?
Yes.
Okay. So, do we need to do a big calculation here or what? Simple? What? What's the answer? It's going to be M times HF. So what's the answer?
33,000.
33,000, right? So it's going to be this times this, so 0.1 times 330,000 is going to be 33,000, right? Is that correct? All right, so E equals 33,000. And that's joules, correct? All right, good. Let's see. In this question, you will combine your understanding of power with your new knowledge of latent heat. They're trying to make it sound very exciting. Huh? Are you excited? You look excited. Are you excited? Okay. I need to erase this. All right, so right away, let's see what they said. All right, it says power. Do you remember what power is? The equation for power? What is it? Power equals work over time, correct? Yeah, okay. And it says, let's see, the latent heat of vaporization of water is 2.3 times 10 to the 6, right? 2.3 times 10 to the 6 joules per kilogram, correct? All right. It says the thermal energy supplied is 460 watts. That's going to be H what? HV. The power is going to be 460 watts. Is that correct? Yes? Sorry, don't count. 460 watts. Okay. It says calculate the mass of the water. What am I going to do? What's the equation? Let's write it over here. Let's write a different color. Let's go completely crazy. What's the equation?
Energy is equal to N.
HV, right? And then solve for M. E, yeah. E divided by HV. So, what's E going to be?
460 watts.
What is it?
460 watts.
That's power.
No, sir. 2.3 times 10 to the power of 6. Because it's joules.
Right, but we're missing something. What are we missing?
The time.
And what's the time? It's in the problem.
Yes.
I purposely didn't tell you. What's the time?
180.
What is it?
I don't remember.
We'll take out your paper.
180 seconds.
180 seconds. Right? Because, remember, power is work over time, or E, in this case, E over T, right? So, I need to find out, I need to multiply this by time. If I multiply this by time, the time cancels, and I'm left with the work, correct? Yes? So I want to multiply this by this, correct? Yes? So I want to multiply 460 by 180. Clear? So what is 460 divided by, times 180? 460 times 180. What is that?
82,800.
What is it?
82,800.
82,900?
800.
800. Okay. So the total E is going to be 82,800 joules. And we know what HV is. So M is going to be 82,800 divided, and we know that we have seconds, watts, joules, kilograms. We're cool. Okay, so 82,000 over 2.3 times 10 to the 6th. That's about a third, plus it'll be over 2 decimal places. So what's the answer? M equals 0.033, 32, 34, what? 36? How do you know it's kilograms? Because everything was analyzed prior to the problem. Okay, you have to analyze the dimensions every time you do a problem. And the IGCSE is unforgiving when you're supposed to put in your unit labels and you leave them out. They don't give you any credit. Clear? So be careful, okay, with that. All right? All right, we're finished that. All right, that's that worksheet, yes? And we'll finish. All right, we'll do another one.